Welcome back to our Chem 152 video series. In this video, we'll go over how to interpret reaction mechanisms. Our mechanism for this problem has three reactions. All three reactions will combine to make one single reaction. To find out what that single reaction is, we must first identify the intermediates inside of this system of equations. An intermediate is anything that is made in one line and then used in a later line. In line 1, we can see that Cl gas is something that gets made. But if we look to the later lines, we can see in line 2 and line 3 both, we'll use up the Cl's. Therefore, one of our intermediates will be Cl gas. We can also see in line 2 we've made COCl and then immediately used it again in line 3, which means another one of our intermediates is COCl gas. Therefore, our intermediates for this system are Cl gas and COCl gas. To complete part B and find the overall reaction, what we can do is cross the intermediates out and see what's left. Now we'll draw a line through the arrows. Now let's examine the left side of the equation. We can see that Cl2 gas remains and CO gas remains, and so we'll write them below. If we look on the right side of the equation, we see that the only thing that remains is COCl2 gas. This will be our product. Therefore, the reaction Cl2 plus CO yields COCl2 is our overall reaction. So from the system of three equations, we combine them together to make one single equation. Part C asks us to eliminate the intermediate to write the rate law for the slow step. To begin writing the rate law, we'll say rate is equal to K times the reactants in that step. And we're going to start with the slow step. The slow step is the second line, and so we'll say rate is equal to K2, because the directions say to use K2 for that reaction, and then the reactants are CO and Cl gas. However, we said previously that Cl is an intermediate. Anytime you write a rate law, you cannot write intermediates. Therefore, our goal will be to eliminate the Cl. In order to eliminate the Cl, we will now write another equation for line 1. The reason why we do that is because line 1 produces Cl, which we later use in line 2. Therefore, we'll go back to line 1 and try to do some algebra to solve for Cl. The equation we'll write for line 1 is going to be slightly different from line 2. The reason for that is because line 1 is an equilibrium reaction. Therefore, we'll have to write an equation that equates the left side to the right side. On the left side, we have Cl2, and on the left also, we'll use K1 as our K value. So we'll say K1 times Cl2 on the left side. On the right side, we'll look to the right side of our equation, and on the right of line 1, we have 2Cl. Therefore, we'll write Cl, and that coefficient of 2 tells us to square the Cl on the right. That's different from writing the subscript of 2 on the left. Also, the K value we'll use on the right will be K-1. As indicated in the description above, that is the reverse rate constant. Now, we'll do the algebra to solve for Cl. We will try to get the Cl by itself. Therefore, we'll begin by dividing by K-1. When we divide both sides by K-1, we'll end up with Cl squared equals K1 over K-1 times Cl2. Then, if we take the square root on both sides, we'll end up with Cl on the left, no longer squared, equals square root of K1 over K negative 1 times Cl2. Now to complete this process, we'll take our Cl and plug it in to the Cl position that I've circled in orange above it. This expression will be placed in place of that Cl. We will substitute the Cl with the square root equation we came up with by doing the algebra. When we make that substitution, we will end up with rate equals K2 times CO times square root of K1 divided by K negative 1 times Cl2. Usually by convention, when we write that rate law, we write the K's before we write the concentrations. So we can say rate equals K2 times K1 over K negative 1 under a square root times CO times Cl2. And that square root that's around the Cl2 we'll represent as 1/2 power. Therefore, this is the completed rate law for the slow step of our system. Thank you for watching, and we'll see you again soon.